Simplify. Variables represent positive real numbers. In this case, this variables represent positive real numbers. We say this before a lot of problems because we're not allowed to take, say, square roots of negative numbers, or fourth roots of negative numbers, or sixth roots of negative numbers. But we can take third roots of a negative number, or seventh roots, or fifth roots, any odd power. So this wording doesn't affect us at all because we're allowed to do a cube root no matter what we have. We're allowed to do this cube root no matter what x is. So yeah, okay. The variables are positive, but in this instance it doesn't matter. But keep that in mind why we often say that. So we'd like to simplify this. So we'd want to cancel whatever cancels. It's a fraction after all, and that's what we do with fractions. If there was more than one term, there isn't, right? There's no addition or subtraction. Then we would want to combine like terms. These are the standard simplify type things. So let's go ahead and do that as best as we can. Why don't we go and rewrite this cube root a little bit first. Recall that if I have a root of a product, that I could just as well take the root of the first piece of the product and the root of the second piece of the product and then multiply those results. So we can do that here. We can rewrite x to the 5/3 over cube root of 8x squared by taking that denominator and breaking it into two pieces. Cube root of 8 times cube root of x squared. So there's some progress for us. Cube root of 8, of course, you'll recognize is just the number 2. Okay, so we'll be able to simplify that in a moment. That part's equal to 2. What about x's? We have some cube roots of x's here. We have 2 of them, and we have some cube roots of x's here, right? That's what this 3 in the denominator means. We have 5 of them. So we should be able to cancel some. If we go ahead and rewrite this cube root in our exponent notation, maybe it'll be easier to see how much gets canceled. I'm going to replace cube root of 8 with 2. I'm going to rewrite this in exponent notation instead of a cube root. I'll write it as a 1/3 power. Since I have something squared there, that 2 goes up in the numerator. All right, so we have this. We can easily see what cancels by just using rules of exponents, right? I have x to the 5/3 in the numerator. I have x to the 2/3 in the denominator. I can do that. Same basis, so I just subtract the exponent that showed up in the denominator from the one that showed up in the numerator. I still have this 2 sitting in the denominator, so I'll copy that down. Little bit of arithmetic. 2/3 from 5/3, common denominator, so I just subtract 2 from 5. I'm left with a 3, so this is x to the 3/3, still divided by 2. 3 over 3, that's 1, so this is x in the numerator and 2 in the denominator. And there is our simplified form. Right? If we didn't want to go to rules of exponents to combine our x to the 5/3 and our x to the 2/3, another alternative that we could have, I changed colors of the pen. Another alternative, it's not changing colors on for me. Change colors. No? Just a second. After much struggling, I got my other color. I don't know what was wrong. All right, so I have to remember what I was going to say now. Instead of using rules of exponents, what we could do is we could recognize that 5/3, that's something greater than 1. In fact, it's 1 plus 2/3, right? So I could rewrite x to the 5/3 as x to the 1st times x to the 2/3. Right? We combine exponents by adding 1 plus 2/3 to give us the 5/3. So x to the 5/3 is the same as x to the 1st times x to the 2/3. There's still a 2 in the denominator, still an x to the 2/3. And now we say, oh, x to the 2/3 appeared in both places. So we could go ahead and cancel those, and we would be left with x over 2, the same as we got there.